Good morning, class. Welcome back to AUM, but now we're an online class. Uh, so this video, I hope, will be about 15 minutes long. It's the first of probably three on normal distributions. I hope you have your exercise set 9 in front of you and a copy of the area table for the standard normal distribution. It'll be a little easier to follow what I do if you have those documents in front of you. Okay, so this morning we're going to be concerned with the topic that's designated as letter A in your exercise set. We're going to be doing simple geometry. We won't see the connection to probability theory until the second and third videos. So we have our standard normal curve. I displayed it for you in class using the graphing calculator, and it has the shape of a bell. So it extends from minus infinity to plus infinity. So that if we consider a region whose boundaries are the curve and the horizontal axis, this region extends forever in both directions. Despite that, the area of the entire region, the area under the whole curve, is exactly 1 unit. 1. You remember there was a funny looking constant in front of the formula for the standard normal curve, 1 over square root of 2 pi. And that's a fudge factor to adjust things so the area under the curve will be 1. Now, in part A, what we're learning is how to find areas of parts of the region. So we have, this is the sort of problem that we'll be concerned with. We have either 1 or 2 values of z. So maybe we have a value here and a value here. And we want to find the area that those 2 vertical lines cut off. So we can have 2 values of z, and then we will have a finite interval. Or we might just have 1 value, and then the region would go on forever. So how do we find the areas of those regions? So for this morning, it's just simple geometry. We won't see the connection with probability theory until later. Okay, so let's consider the case where we have 2 values of z. I'm going to do 5 or 6 easy problems for you. So the first one is this. We have the number 0, and we have a positive number for z. So let's suppose that positive number is 0.82. And what we're trying to find, let me try a different color, maybe it'll be better, is the area that I'm shading here. So here's how we would notate that. So the area between 0 and 0.82. region there. So this is, in natural language, to use math notation, we would write it like this. This is the letter Z here. So how do we find that? It's the simplest thing in the world to find that area. We take our standard normal distribution area table. We find the digit 0.8 in the left column and the 0.02 in the top row. And we just see. So we have, we'll use the table. We have 0.8 in the left column and 0.02 in the top row. And we just follow our eye and we see what that number is. And that number turns out to be 0.2939. That's our answer. Okay, that's our first problem. Sorry for my bad handwriting. 0.2939. Okay, so this is actually a probability value, as we'll see later. The probability that Z falls in the interval from here to here is 0.2939, about a 29% chance. Now, let me mention up front that this is less than or equal to, less than or equal to. If it's less than, it doesn't change the answer, surprisingly. That's not what you would expect, I imagine, because if we were in our earlier discussions about probability, if we make this an open interval rather than a closed interval, it would be a different problem. But same answer here. Okay, so our second problem is, suppose this value had been negative. So we go from minus 0.82 to 0. All right, let's see how that goes. So here's our curve again. All right, so what's this area? Minus 0.82 to 0. Well, do you see that the curve is symmetrical? The region that we had previously, this is just its mirror image if you think of the vertical axis as a mirror. So this region has the same size exactly as the previous one. So the answer is the same as it was. It's 0.2939. It's plus 0.2939. Not minus 0.2939, even though this is a negative Z value here. So the area from 0 to a given positive number is exactly the same as the area from 0 to the corresponding negative number. You'll notice, by the way, that on your exercise set, you have 15 problems, I believe. The answer to every one of them is a probability value, so it's between 0 and 1. Whenever we're finding probability values, we get answers between 0 and 1. All right, third problem. Let me see here. Suppose we have a negative value and a positive value. so let me draw the curve again. All right, so let our interval extend from minus 0.82 to plus 1.53. So here's minus 0.82, here's plus 1.53. All right, let me draw a curve. Okay, how do we handle that? Well, here's the idea. So we want the area of this region. So we have, it's in two pieces, isn't it? The part that's to the left of 0 and the part that's to the right of 0. All right. Well, this part we just finished. We found that in problem 2, and the other part we can find as we did in problem 1. So the whole is the sum of the parts. The region that we are considering consists of two pieces. We just add their areas together. So the probability that z is between minus 0.82 and plus 1.53 is problem 2's answer. That was 0.2939. Plus the area from 0 to 1.53. So we look that up in our table. We find 1.5 here and 0.03 here. We follow our eye over, and that number turns out to be 0.4370. So we just add these two values together. And the answer turns out to be 0.7309. Hope you can read that. 0.7309. Now, notice this number is negative, this number is positive, but both of these values are positive. A common mistake is to think that since this is negative, this should be negative. So when you have a negative value and a positive value as your endpoints of your interval, both terms will be positive. All right, so that's the third problem. Now, suppose the left endpoint had been plus 0.82 rather than minus 0.82. What happens then? All right, so let's draw another figure. Here's plus 0.82, here's plus 1.53. All right, so how are we going to find that area? Here's what we do. We can't look the area up directly using our table because it doesn't start at 0, it starts at 0.82. So we just fill the region in so that it does start at 0. We add extra area. So we can look up the area from 0 to 1.53. It's right here. And I hope to get better at using our setup here. This is our first video. I hope my skill will improve. All right, but this number includes this piece here that we don't want in there, so we subtract its area out. And subtracting, we get 0.1431, I believe. Okay, now, so here we have two z values that have the same sign. This is a positive number, this is a positive number. But these numbers don't have the same sign. This one is positive, this one is negative, because we're subtracting the area of this piece that we don't want. So when the signs are the same, we have different signs here. And when the signs are different, as we saw in the previous problem, we have two positive numbers, we have the same sign. Okay, finally, suppose we only have one endpoint rather than two. All right, so let's look at the area from 0.82 to infinity. So here's 0.82, and we go to infinity here. All right, so this is called a tail, TAIL, under the standard normal curve. So we're trying to find the probability that z is greater than or equal to 0.82, excuse me. How do we do that? Okay, previously I mentioned that the area under the whole curve is exactly one unit. Now here's the trick that we use. We add in or enlarge the region so that it starts at 0. Now, the part that's shaded green plus the blue part taken together is a half. Why is that? The total area under the curve is exactly 1. I've cut it in half. Remember when we were finding medians, we were doing that. So half of 1 is 0.5000. So the green plus the blue has area 0.5000, and but we don't want the green. We want the blue. So we subtract the green area. Well, that goes all the way back to problem 1, doesn't it? So we subtract 0.2939, giving us an answer of I believe 0.2061, if I'm not mistaken. Okay, so you now have the tools to do part A of the ninth exercise set. Now class, let's have a good experience here at the end of the semester. I want to hear from you. So send me an email or give me a call. At a minimum, I want to know that this material is getting to you. So this is our first YouTube on normal distributions.